Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Tuple with same product, Leetcode 1726. In this problem, we are given an array nums of distinct positive integers and we should return the number of tuples a, b, c and d such that a into b is equal to c into d, where a, b, c and d are the elements of the nums array such that a is not equal to b and c is not equal to d. Then in example 1, for the given nums array, we have 4 elements and we have 8 valid tuples. This is because when we multiply 2 by 6 and 3 by 4, we get 12, and since the product of these pairs is equal, we can form tuples. Similarly, we will be forming remaining tuples with each pair having product equal to 12, and hence 8 will be our answer. Then in example 2, for the given nums array, we have 16 tuples. Because we can form 8 tuples with product 10, for example 1 into 10 is equal to 2 into 5 is equal to 10, and similarly for remaining 7 tuples here. And we will form another 8 tuples with the product 20, because 2 into 10 is equal to 4 into 5 is equal to 20, and similarly for the remaining 7 tuples. So we will get total of 16 tuples. Now before going into the solution space, let's make some observations. First of all, notice that it is not a coincidence that we got 8 tuples in example 1 and a multiple of 8 in example 2. Let's look at this generic tuple with elements a, b, c and d, where all of these elements are distinct and satisfy the condition that a into b is equal to c into d, and we will get 8 tuples from this arrangement. So first tuple can be that we get a into b is equal to c into d. This will give us a tuple a, b, c and d, and then we swap c and d. So we will get a into b is equal to d into c, which is equal to the tuple a, b, d, c. So this gives us 2 arrangements. Similarly, we will swap a and b on the left side, resulting in 2 more tuples. So we got total of 4 arrangements when a and b were on the left and c and d were on the right. But now we move a and b to the right and c and d to the left. So this will give us total of 4 more arrangements. And hence we will get total of 8 permutations in this case. And this is what was happening in the example 1, where we had these numbers 2, 6, 3 and 4, where multiplying 2 by 6 and 3 by 4 will give us 12, and the first tuple will be 2, 6, 3, 4, and then rest of the tuples will be permutations of 2, 6, 3 and 4, resulting in total of 8 permutations. And now for second observation, let's look at slightly bigger example. Let's take nums as 1, 2, 3, 4, 6, 8, 12, and here we can have multiple pairs which can form the tuples. For example, one pair can be 1, 6 and another pair can be 2, 3. Both the pairs result in product of 6, resulting in 1 tuple and hence 8 permutations. Or we can have 2 pairs, 1 and 8 and 2 and 4, both resulting in the product 8, resulting in 1 tuple or again 8 permutations. But now comes the interesting case. We have 3 pairs resulting in the product of 12, and those are 1 and 12, 2 and 6, and 3 and 4. And now the question is, how many tuples can we form? Let's derive that. Let's denote these pairs as P1, P2, and P3. Then we can form the tuples like P1, P2, or P2, P3, or P3, P1. That is, we can take one tuple like 1, 12 or 2, 6, or we can form the tuple like 2, 6 and 3, 4, or we can form the tuple like 3, 4 or 1, 12, right? So in total, we can form 3 tuples, resulting in total of 24 permutations. And now this gives the impression that number of pairs is equal to number of tuples, but this may not be correct. Now suppose instead of 3 pairs, we found 4 pairs and let the 4th pair be P4. Then we will be getting total of 6 tuples instead of 4. Why? Because the 4th pair P4 can go with or combine with each of P1, P2 and P3, resulting in 3 more tuples. Hence total of 6 pairs or 48 permutations. And now let's extend it a bit. Suppose we got 5 pairs with equal product, and with the 5th pair being P5, then how will this extra pair contribute to our answer? And the answer is, it will contribute 4 additional pairs because it can combine with existing 4 pairs P1, P2, P3 and P4 to contribute extra 4 pairs, resulting in total of 10 pairs. And mathematically speaking, we are choosing 2 pairs out of n pairs to form a tuple. And this is where combinations formula kicks in. When we choose r items out of n items, that formula is denoted by NCR, which is equal to n factorial divided by r factorial and n minus r factorial. And here r is equal to 2. So NC2 will be equal to n factorial divided by 2 factorial into n minus 2 factorial, which we can rewrite. In the numerator, we can rewrite as n into n minus 1 into n minus 2 factorial. And in denominator, 2 factorial becomes 2. And we can write n minus 2 factorial as is, which we can cancel out. So NC2 will be equal to n into n minus 1 by 2. So that's why if we have 4 pairs, then our answer will be 4 into 3 by 2, that is 6 tuples or 48 permutations. And now once we have this understanding, we can delve into the solution space. Now in terms of solution, one of the naive approach can be to iterate over all possible quadruplets A, B, C, D and check if they satisfy the condition that A into B is equal to C into D. This can be achieved using 4 nested loop, say with iterators I, J, K and L, resulting in a time complexity of O of n to the power of 4, which is extremely high. And the question is, can we do better? And the answer is yes, of course. We don't need to use 4 nested loop for that. We just need a pair of products to be equal to form a tuple. So we just need to run a nested loop to find all pairs, and then we have to find if any pair is equal to them in terms of product. And this is where hash map or frequency map can help us, because we can store the product of pairs in the map, and whenever we encounter a product with a frequency greater than 1, that means we can form tuples. For example, for this input array, the product of pairs will be 1 into 2, 1 into 3, 1 into 4 and so on. And now we can store the frequencies of these products in the map. For example, products 2, 3 and 4 occur only once. Products 6, 8 and 48 occurs twice. Products 12 and 24 occurs thrice and so on. And now whenever the frequency of the product is more than 1, we can form tuples. And how many tuples can we form? If the frequency of product is f, then the number of tuples we can form is by the combination formula FC2, which is f into f minus 1 by 2. And now let's look at the frequency map and calculate number of tuples. We can filter out all the products with frequency 1 because we cannot form tuples from them. So we rule out the products like 2, 3, 4 and more. Now let's look at products with frequency 2, that is 8, 6 and 48. From them we can form 2C2, that is 1 tuple each, resulting in total of 3 tuples. And we have 2 products with frequency 3, that is 12 and 24. That results in number of tuples as 3 into 3 minus 1 by 2, that is 3 tuples for each product. And for these 2 products, we will get total of 6 tuples. And combining these, we will get total of 9 tuples. And since each tuple has 8 permutations, total number of permutations we will get is equal to 72. Now let's jump into the code part. First, let's create a hash map to store the frequency of each product of pairs of numbers from the input array. Let n be length of the nums array. Now we will run the nested loop on the nums array to find all possible pair of elements. The outer loop goes from I equal to 0 to end of the array, and the inner loop starts from I plus 1 to avoid multiplying a number by itself and goes up till end of the array. Then we calculate the product of pairs of numbers at ith and jth index and update the occurrences of each product. If the product is not present, then we will default its value to 0 by using get or default method, and in any case we will increment the frequency of the product by 1. Initially our answer will be equal to 0. It will store number of valid tuples. Now we will iterate through each frequency in the product map and check if the frequency or count is greater than 1. In that case, we can form multiple pairs in numbers that have same product, which will be equal to count C2, that is count into count minus 1 by 2. And once we have calculated total number of tuples, we will multiply our answer by 8, accounting for 8 different permutations. Now let's submit this code. Cool. Now in terms of time complexity, it will be O of n square, where n is the length of nums array Because first we iterate through all the pairs using the nested loop and calculate all the products and save them in the frequency map. And then we go through the frequencies as well. So because of this, the overall time complexity is O of n square. And in terms of space complexity, it will be O of n square in the worst case if all the pairs have unique products. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.